Let's continue looking at section 5.5. Today we are going to look at more properties of parallelograms, rectangles, rhombi, and squares. All right, so we're just going to do another example. Once again, just remember there are 5 properties of a parallelogram. And since I'm giving us a parallelogram because of that symbol, we know that the 5 properties are opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. So first and foremost, I would mark up my picture with the given information, and then we can determine what properties from that list of 5 is going to benefit us in this problem. So not only do I have a parallelogram, I'm told that angle P is 2x plus y. I'm told that angle M is 3x plus 5y. I'm told that angle T is 4x minus 3y plus 8. All right. So notice that every single thing in this was given to us as an angle. So that means there were 2 properties of angles. Opposite angles are congruent and consecutive angles are supplementary. So we have several different things here. We do have opposite angles in this picture. Notice the angle P has an expression and so does angle T. So I know that because opposite angles are congruent, 2x plus y is going to equal 4x minus 3y plus 8. Otherwise, we do have several sets of consecutive angles. Notice that angle P and angle M, which both have expressions, are right next to each other. So they're consecutive, they are supplementary. Angle M and angle T both have expressions. They are right next to each other. They are also consecutive, so they're supplementary. So I only have to pick one more in order to set up a system. So you can say that angle M plus angle P equal 180, or you can say angle M plus angle T equal 180. So I'm going to do angle P and angle M. So I'm going to say 2x plus y plus 3x plus 5y equals 180. All right, so now that I have 2 equations, because I have 2 unknowns, I'm going to start manipulating. So I'm going to get the x's and the y's to the same side in this top equation. So I'm going to subtract the 4x over to the other side. I'm going to add the 3y over to the other side, and then the number's already there. In the bottom, we just have some like terms to combine. Otherwise, everything is on the side where it needs to be. So my top equation, we will now have a negative 2x plus 4y, and that's going to equal 8. My bottom equation, when I combine like terms, gives us 5x plus 6y to equal 180. All right, so I have it set up in order to potentially do elimination. But now when I start looking, I see that there's nothing that's going to add up and eliminate right away. My smaller numbers are actually in the top row, and I can't turn 2 into 5 very easily. I can't turn 4 into 6. So that means we are going to multiply both equations. So because the x's are already opposites, I think I'm going to do that. So the top equation, I'm going to multiply by positive 5. And then in the bottom equation, I'm going to multiply by positive 2. And that's going to get me opposites for x, so then the x can disappear. So if I distribute the 5 on the top, we'll have negative 10x plus 20y, and that's going to equal 40. In the bottom equation, we're going to have a positive 10x plus 12y, and that's going to equal 360. And now I have opposites where I can add up the x's and have them disappear. The y's are going to add up to 32y, and then this is going to add up to 400. So then I'm going to divide both sides by 32. And so when I divide by 32, I get one of my answers because I want to find x, I want to find y, and then I want to find the measure of my 2 angles. Well, y looks like it's going to be 12.5. All right, so now that I have y, I can definitely solve for x. I can go back to any of my equations. I think I'm going to go back to the original equation here where I have negative 2x plus 4y equals 8, just because those numbers are a lot smaller. So if I have negative 2x plus, now I'm going to have 4 times this 12.5, and that's going to equal 8. So if I multiply 4 and 12.5, it's going to give me 50. So then I'll subtract 50. I'll get negative 2x to be negative 42. And then I'll divide both sides by negative 2. And so when I have negative 42 divided by negative 2, it's going to give me a positive number, and it's going to give me 21. So I have half of my answers. I've got x and y. Now I need to find the measure of angle P and the measure of angle S. So here's half of my answer. So to find angle P, I can very easily just substitute in the values that we got for x and y. So we'll have 2 times 21 plus 12.5, and that'll give me the measure for angle P. All right, so we've got 2 times 21 is 42. When I add 12.5 onto it, we're going to get, a 54.5 degree angle. Okay, notice that the other angle that they're looking for is angle S. Angle S is the only angle that doesn't have an expression. So there's 2 ways that we can think about this. Angle S is consecutive to angle P. And consecutive angles in a parallelogram are supplementary. So because I already have the measure of angle P, I can very easily find the measure of angle S by taking 180 minus 54.5. The other way I could have thought of it is that angle S is opposite and across from angle M, and in a parallelogram, opposite angles are congruent. So I could have also just substituted x and y into angle M, and that would have given me angle S as well. But if I subtract 180 minus 54.5, I'm going to get 125.5 degrees. So there's the other half of my answers. All right, let's talk about some shapes that we haven't already talked about. One of them is a rectangle. So a rectangle is a parallelogram with at least one right angle. So that's why it was important for us to know what a parallelogram is, because a rectangle is a parallelogram. And so what that means is that all of the characteristics of a rectangle, all the characteristics of a parallelogram, so those 5 properties of opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other, those properties also are properties of a rectangle. We have a rhombus. A rhombus is a parallelogram with at least 2 consecutive sides congruent. So a rhombus is a parallelogram, means that the 5 properties that we listed for a parallelogram are also properties of a rhombus. A square is a parallelogram that is both a rectangle and a rhombus. So essentially, as I continue to come up with these properties, so a rectangle has 5 properties, which are the properties of a parallelogram, plus they'll have some extra ones because now I know I have right angles, and there's other properties as well that I'll give you a list. I'll give you a checklist with all the properties. Okay, a rhombus is going to be a parallelogram, so those 5 properties. When it says consecutive sides are congruent, so here, let me sketch a picture really quick. So with a rectangle, I know that we're going to have at least one right angle. I know a whole bunch of other stuff as well, but understand that if I have at least one right angle, that technically means that all of them are right angles, because remember, with a parallelogram, opposite sides are congruent. Opposite angles are congruent. So if that's a 90-degree angle, so is this one. And consecutive angles are supplementary. So 90 plus what gets me 180? Well, another 90. So then essentially that's why all of the angles are right angles. When I have a rhombus with at least 2 consecutive sides congruent, so we don't know that we have any right angles. So that's why we have that little, shift on it or that little bend to it, just like a parallelogram. But consecutive, remember, means that consecutive is right next to each other. So at least two consecutive sides congruent. So that means if these two sides, which are right next to each other, are congruent, but we understand that a parallelogram has opposite sides congruent, well, that means that all of the sides are actually going to be congruent when we have a rhombus. A parallelogram is both a rectangle and a rhombus, so that means that there are right angles and all four sides are congruent. So put it all together. So here are just a couple of little sketches of my figures. All right, so if you check the extra resources, you'll see a PDF of a checklist of all the different properties of the parallelograms, the rectangle, the rhombus, the squares, and then there's a few other shapes that we just haven't learned yet. But you're going to want to always have that checklist handy because that's going to help us when we're doing these algebra problems. So notice that in this particular problem, we are told that JKMP is a rectangle. Okay, we're also told that PK, which is a diagonal, we're told that that is 0.2x. We're also given that JM, which is a second diagonal, is x minus 12. So if we take a look at that checklist that I said that I have in the extra resources, one of the things that you'll see if you look at all of the x's in the column for rectangle, you want to go down to where they're talking about diagonals because in this picture, that's what I'm giving you. I'm giving you diagonals. So we know based off the fact that a rectangle is a parallelogram that diagonals bisect each other. However, because in this problem, I'm giving us the full lengths of those diagonals, another thing to know that in a rectangle, diagonals are congruent. And so because I'm giving you what both of those diagonals are, I get to set them equal to each other. So 0.2x is going to equal x minus 12. So that means I'm going to subtract x to get those to the same side. That's going to give me a negative 0.8x to equal negative 12. And then I'm going to divide both sides by a negative 0.8. Oops. And so when I do that, I'm going to get a value of x to be 15. Now, x is not what they were asking for. They want us to find the measure of pk. So I can find that length by taking my 0.2 and multiplying it by 15. So 0.2 times 15 is going to give us a length of 3. Okay, but we use that checklist that I have in the extra resources. Diagonals are congruent when we're talking about a rectangle. All right, here we have a rhombus. I'm telling us that angle 1 is represented as 3x and angle 2 is represented as x. We want to find x and then find the measure of the angle ADC. Well, hopefully we notice that angle 1 is being formed by two diagonals. It's being formed by the diagonal of AC as well as the diagonal of BD. And so if we take a look at that checklist, if we're looking at a rhombus, hopefully we notice that when we're dealing with diagonals, one of the characteristics is that the diagonals are perpendicular. So perpendicular means that they're forming right angles. So notice that angle 1 is given to us to be 3x, but it's also a right angle, which is 90 degrees. So since I have two things representing the exact same angle, that's how we're going to solve for x. I get to set those two things equal to each other. So all I have to do is divide by 3, and I get a value of x to be 30. So there is half of my answer. Now what it's asking for us to find is the measure of the angle ADC. So if you look very carefully, the angle that I'm looking for is not just angle 2. It is going to be more than that, okay? But if we look at our list of properties of a rhombus, hopefully we notice that this diagonal of BD is interfering with us finding the length or the measure of angle ADC. But one of the properties is that the diagonal of a rhombus bisects the angle. So once I find what the measure of angle 2 is, that's also the measure of the angle right by it, and together they form the angle that I'm looking for. So since I know that angle 2 is x and x is 30, the measure of angle ADC is honestly me just doubling that, because once again, I know that x is 30 and I know that a diagonal is bisecting the angle of a rhombus. So 30 plus 30 tells us that we have a 60-degree angle. All right, let's look at a square. So we're given GHIJ to be a square. We want to find the value of B. So notice that we are given 4B to be one side and B plus 45 to be the other. We're first talking about finding B. Well, B is dealing with sides of a square. And if we looked at our properties, at our checklist, when we're looking at a square, one of the things is that all the sides of a square are congruent. So that means that in this problem, 4B is going to equal B plus 45. So I'll subtract B to get that to the other side. That gives me 3B to be 45. And then I'm going to divide by 3, and I'll get my first answer. B is 15. Then it's asking for us to find the perimeter of the square. Well, to find the perimeter means that I want to add up all the sides. The nice thing about this is that all the sides are congruent. So I can substitute B into any of the two expressions that are given. So if I plug it into the 4B, we're taking 4 times 15, which is going to give us 60. So that means that every side is 60. So the perimeter is us adding 60 4 different times, or a faster way would be us taking 60 and multiplying by 4. So it looks like the perimeter is 240. Okay, so that's us using properties of parallelograms, rectangles, rhombi, and squares.